End behavior of polynomials. For example 1, if the degree is odd and the leading coefficient is positive, then the graph will look like this. Example 2, if the degree is odd and the leading coefficient is negative, then the graph will look like this. Example 3, if the degree is even and the leading coefficient is positive, then it will look like this.
Like a little butt.
Example 4, if the degree is even and the leading coefficient is negative, then the graph will look like this.
Your upside down butt.
Ah!
Number 4 in the practice test. Find all real solutions using synthetic division given one possible solution of f2 for fx equals x cubed plus 4x squared minus 3x minus 18. So first, you take this 2 and you put it out there. And you put the 1 for negative 3 and negative 18 because those are the numbers in the equation. So you drop the 1, and so then you multiply 2 times 1, which is 2. And so then you do you add 4 and 2 together, which is 6. So then you multiply 6 and 2, you get 12. Then you do 12 plus negative 13, which is 9. Then you do 9 times 2, which is 18. Negative 18 minus 18 is 0. So that means that this equation levels out. So it's x minus 2 from this 2. And you turn it into a factoring thingy, a trinomial. Just an x squared plus 6x plus 9. When you factor that, you get x plus 3 and x plus 3 and times x minus 2. So you set those equals 0. You get x equals 2, x equals negative 3. And you go down. And your factors are 2 and negative 3. Woo!
Trace.
1, 2, 3. Factoring polynomials with the sum of two cubes. A cubed plus b cubed equals a plus b multiplied by a squared minus 2ab plus b squared. This is the formula we're giving to find the following example. Y cubed plus 125. So what you're going to do is you're going to factor a 5 to make it y cubed plus y cubed. Plus 5 cubed, correct me, okay. Y plus 5 around the parentheses of y squared minus 10y plus 25. That is when you use FOIL to get the next step. Then, when you get that, you're going to get y plus 5 around the parentheses of y minus 5 squared. This is Pascal's triangle. There are 5 rows that follow a pattern with ones on the outside that all add to certain numbers in the middle. An example of this triangle is 2m plus n cubed, which we then realize is the third row, which is 1, 3, 3, 1, 1, 5. So when you break it up, you're going to get 1 times m cubed times n, 0. Notice how when you go through the equation, the numbers count down right here, and then they curve back up. So when you add these all together, you're going to get this long line. And when your final product, when you add up, all these numbers together to get all fancy numbers, you're going to get 8m cubed plus 12m squared n plus 6mn squared plus n cubed. That's Pascal's triangle.